Hello, everyone, and welcome to the last session of the 2022 Winter Ag Workshop Series. I'm Cassie. I'll be your host today. Today, we are joined by Phil Clauer, and he'll be discussing poultry and how you can bring it into your classroom. First, a little bit of housekeeping. In the chat box, there is the pretest. If you haven't taken that, please do so. Also, Phil put his email in case you have questions, so you can write that down. Now your video and audio are off, so you'll need to use the chat to talk to us or anyone else. For this session, please use the Q&A box, not the chat box, if you have a question. It'll help us see them a little easier. And everything is visible. This is being recorded, so please be respectful and everything like that. So with that, let's welcome Phil.
Okay, so I guess you want me to start right up. We're ready to go, I guess.
Yep, ready to go.
Let me share my screen and turn off my mug shot. You don't have to see me all while we're doing this. Okay, let me pull up there we go. So today what I'd like to do is introduce you to, I've got multi-parts to my presentation. And partly what I'm going to do today is introduce you to some of the resources we have through Penn State Cooperative Extension and is used by our program. So the first thing is a lot of people don't understand that we have a 4-H embryology in the classroom program. We've had it for years. I was the national program leader before I even came to Penn State 21 years ago. It enrolls about 40,000 students in schools a year in Pennsylvania. And there's a number of resources that are available. And we've revamped this quite a bit during COVID, basically because of necessity and not being in person, all that stuff anymore. So just start off, just to give you an idea what the 4-H embryology program looks like a little bit so you can see what we have, is it's basically offered from 2nd grade through 6th grade. And we have some high schools that also participate in this program, but it's mostly 2nd to 6th grade. It's a full 21-day incubation period project. So it's expected now, it's actually a requirement of the program to run the full stage of incubation. There used to be some counties in the eastern part of the state that got pre-vaccinated eggs and just hatched them and handled the chicks, and that was it. There was no education with it. So it's now has gone to mandatory. That's a 21-day project. You need to enroll into this program through your county extension office, through your county extension 4-H educator. They run this program. Depending on what county in the state, some counties have a slight enrollment fee, but they provide the incubators, the fertile eggs, a whole lot of other resources, as well as a technician that comes into your classroom and helps teach things. So it varies a little bit from county to county and what is offered, but they are out there. We have publications, which is the first one at the bottom here you see is a national publication on experiments in poultry science. It's more of a hands-on type of manual and some things you can do above and beyond in the classroom. Then we have program manuals that are by Pennsylvania specific, that are like worksheet, quiz, examination type of format. And then we have a website. If you want to know where this stuff is, where you can find this, the website is right here on this slide. It basically go into the 4-H 4-H poultry 4-H program in Pennsylvania and get involved, teachers embryology. It's a little varied, but it's not too bad. My forward button isn't working good today. There you go. Educational objectives of the program is pretty self-explanatory, but not everybody understands some of the things we try to do. Obviously, we do a lot of teaching about the life cycles of observation of embryos, the whole thing about living and learning to care for living things, parts of the egg, development of the embryo, actually development of the egg within the female, we do that. We teach a lot of personal responsibility as part of management and care of these incubators and classroom. We engage students. We don't like to have automatic turners. We like the kids to be involved in the project. We find that if they are engaged and involved, there's less problems with the project. They also self-police it and take care of it pretty well. Science inquiry skills, observation, comparing, measuring, data collection, all that's built into the program. And then we also put quite an emphasis on food and fiber systems in Pennsylvania. And some of it's specific to the poultry industry, but there's a lot also dealing with other commodity groups in Pennsylvania to help people understand the food and fiber system and how important it is to our economy. So just to give you an idea of some other package things, last year, because of COVID, we had to go virtual. And so I didn't change this slide. I should have went and got the newer slide and explained to you, but this can be used right now virtually, or these slide PowerPoint presentations are actually available for use in the classroom for those that are enrolled. There's a 5-part PowerPoint series. The one is the big introduction, really does a capstone of everything you're going to do. And then there's a lot of small Learn Now videos. There's actually fillable worksheets and stuff as part of the program, so kids can answer questions in the classroom, test their skills, and then a whole variety of other types of functions that take place. But the first one's captures everything a little bit. The next one is development of the egg through day 4. Then covers a little bit about living, non-living life cycles in day 4 to 11 in the third one. The fourth one is day 12 to 18 and talks about commodity and agricultural production. And then the final one is hatching, sexing chicks, brooding, food and fiber system. So it covers everything that our program does in a series of 5 lessons that go throughout the program. So just to give you an idea here, I have I'll just run through a quick one of the lesson plans. It didn't go up as quick as I wanted to. There you go. So I'm not going to run the PowerPoint because you can see the slides here very well. And you don't need to see the interactive functions of it, but it goes through and talks about, what is embryology? How do you define it? And this is all interactive. It moves. There's a lot of movement that takes place. It talks about relating this to other animals and gestation periods, how reptiles and eggs and through to chicken, and sort of brings it around to nature and other things that people are surrounded with. Then we talk about in this first one about, the whole aspect of the 4 primary needs for incubation. And then we talk about what that means, and heat, humidity, exercise, and proper air and environmental air and things within your classroom. And so that's all covered in a quick way. Then there's there's always a quick review that they do at the end of each one of these lessons. We have a review that can be filled in. What you're seeing is what has been filled in, but actually they're blanks. And after you have discussion, you can the question, with that question, the answer will pop up. So this slide doesn't really happen anymore. Unfortunately, that one shouldn't be in here because I didn't use the most updated one. I just used one I had my desktop at the time. But the COVID, we still are doing some virtual with these, and people can use them virtually, but it's really going to be meant to be used in the classroom from here on. Talk about incubator placement, such a big part of the program, what's good, what's bad, and so forth. You have an illustration here where the kids can pick out what's bad about this one. There's a lot of things bad about that, but after you learn about what placement's important and what's important, they ask questions. You can have discussion about what's bad about this picture and so forth. Talk about the eggs arriving and what happens. There's a Learn Now video on marking your eggs, preparing them properly for incubation. Talks about getting your incubator set up, gives you a demonstration how to put your eggs in incubator, and goes through all this. Hand washing is a big part of our program. So people hear a lot about hand washing. It's expected for the program to teach this to students to protect the eggs as well as the students. It's more to protect the eggs actually than the students in most cases. And then it talks about the important things again in a little more detail, the humidity, the ventilation, how the work temperature, keep records. Demonstration again, Learn Now video on how to properly turn eggs and place the thermometer and do all the things that you have to do there. I'm sorry, my phone's ringing in the background here. Yeah, I took care of that. And so, you can see and get the gist of this. It shows you things we do in the classroom. We want people to handle eggs in the classroom as they're developing to see what happens. So we Learn Now videos how to do that with a cell phone, with a LED light, those type of things. And then the hatching takes place. that type of thing with the development of the embryo, watching for internal pips, talks about pulling the hatch, setting up a brooder. All these things are in the first PowerPoint. And then there's a little clip about handling chicks. So all of these are active links within these PowerPoints that can be used in pieces or all in one setting. So that's sort of a quick rundown of that. Now I'll go back to our PowerPoint that we're doing. I got to move this thing. There we go. It's blocking my, there you go. So that's a real quick rundown of the aspect of the whole embryology in a classroom from the standpoint of the 5 PowerPoint lessons. Then in addition to that, we have a whole series of training videos that are for the teachers themselves to learn how to run this project properly. But also there's a number of them that can be used in the classroom to help educate the youth as well. So the general program management videos, there's 4 of them. They're mostly about how to do things and do it properly. Some of this cleaning and sanitizing your incubator or the health and hygiene of and safety with the poultry, those can actually be used in the classroom as well as a record tracking and how to do that. But it's really meant more for the teachers, but there are some parts of those videos that could be used to help in the classroom. This one is very specific. It's the development of the fertilized egg within the female's reproductive tract. It explains the whole process from start to finish, from why light stimulation is important for the producing hen, all the way to the eggs being laid. And there's diagrams and moving eggs through the diagrams and so forth. And so the video can be quite educational. It could be used very easily within the classroom to teach that part of the reproductive tract and how an egg forms. Couple other ones, setting up and managing your incubators. So best practices for incubation, how to set it up properly in your classroom so it's useful and get the most out of it. I'll show you one of these videos in a second. Actually, I think I'll show you the embryonic development of chicken and show you how that developed. Just give you an example of one of the videos that are out there. This observation of the embryo through cannling is also a really good one, but I think I'll probably show you the one for embryonic development of the chick in a little bit. And then there's also a whole video on how to prepare your own plastic tub brooder for the classroom. You get the parts, the tools, it walks you through exactly how you can make a brooder for your classroom, proper broodering care and management of the chicks, and then proper handling of the chicks in the classroom, because it's very important if we're going to be handling these at all, that we do it in the best possible way. The final thing that a lot of people don't think about in embryology, but we added it to the embryology curriculum for standards and so forth, is the food and fiber system and what food and fiber is, so we understand what farming is and what processing and marketing is and how big of an industry it is in our United States and in Pennsylvania. And then there's a really good Learn Now video about life cycles and things from resembling to metamorphosis, those type of things. So it talks about the different stages of life for a lot of different organisms, done very well. That's very helpful for in the classroom and meets a lot of educational standards. So real quick, I'm going to close this out again. And then we'll take questions too afterwards and stuff about some of this. So I'm going to play this video now and just let you run. I think it's like 8 minutes, but I'll maybe speed it up along the way.
Let's take a look at the basics of embryonic development from the fertile egg through the hatching of the chick. This amazing process only takes 21 days and is relatively easy to observe in the classroom. It all starts with a fertile egg. Remember, store-bought eggs are not fertile since egg production farms do not keep male chickens. The embryonic development starts with a single female cell, or DNA, called the blastodisc. It is a white spot shown on the yolk to the left and is not fertile. If a male is present in the flock and mating is successful, the male cell unites with the female cell after the yolk is released into the reproductive tract. The cells are then able to multiply as the rest of the egg is forming in the hen. As a result, the spot of the yolk becomes an active blastoderm. Due to the fact that the blastoderm contains thousands of cells, the spot grows and looks more like a circle, shown on the yolk to the right. This egg is fertile. Once laid, the blastoderm can go dormant for 7 to 10 days. Growth does not restart until it is incubated. Once the eggs are placed in the incubator and heated, cell development restarts again. For the first 24 hours, the blastodisc just continues to grow and multiply by successive divisions. During this time, the cells will begin to develop specific characteristics and structures. These cell groupings are called the ectoderm, mesoderm, and endoderm. These 3 layers of cells are what the various organs and systems of the body develop from. At the end of the first day, a blood island appears and begins pulsing. This will be the beginning of the heart and from where the blood vessels will grow. Many elaborate physiological processes take place inside the egg during the transformation of the embryo to the chick. These processes are respiration, excretion, nutrition, and protection. For the embryo to develop without any anatomical connection to the hen's body, nature has provided membranes outside the embryo's body to enable the embryo to use all parts of the egg for its development. These extraembryonic membranes are the yolk sac, amnion, and chorion, and allantois. The yolk sac is the first to become evident. The yolk sac is a layer of tissue growing over the surface of the yolk. Its walls are lined with a special tissue that digests and absorbs the yolk material to provide food to the embryo. The yolk sac is evident as the blood vessels encase the yolk over time. The amnion is the clear fluid-filled sac that surrounds the embryo by the 3rd day of development. The amnion provides protection and allows the embryo to exercise its muscles as they develop. The chorion initially contains the yolk sac and amnion. However, it soon fuses to the allantois and becomes one system. The 4 main functions of the chorion allantois is respiration, handling waste from the kidneys, absorbing albumin, egg white, for protein, mobilizing minerals from the shell to help develop and harden bones and beak. These membranes are very important for the proper development of the chicken embryo and will be evident as you observe the embryo up to hatch. Starting at day 3 of development, you can see things growing and changing. The most notable change is the question mark shape of the embryo. The head is at the curved end, and the heart pulses at the midpoint, where the blood vessels reach out to pull nutrients from the yolk. At day 4, you will see a more defined question mark shape. In this photo, you can see the shape of the body. The gray circle that is the beginning of the eye, the bulges above the head that are the brain lobes, and the heart in the center of the body. Although it is difficult to see, the amnion surrounds the embryo. On day 5, other than a little growth, the embryo looks similar. However, by the 5th day, the sex of the embryo has been determined. On day 6 of development, you can observe many new things. The first, and most exciting for the students, is that this is the first day the embryo can move voluntarily. This video shows a 6-day embryo rocking in the amnion. This is also the end of the chicken embryo's first trimester. All the organs, limbs, eyes, brain, and beak are present. Take a close look at this picture. You can see the limbs, brain, and eye of the embryo. The amnion sac is evident surrounding the embryo as well. From this point, the embryo just needs to grow and develop. During this time, the embryo starts to take up more of the area in the egg. Down feathers start to appear, and it begins looking like a chick. In this candling video, notice the area the chick takes up, the shape of the body, and size of the eye as it exercises in the egg. Take a close look at this picture. You will notice the embryo is starting to look more like a chick. Look closely. Can you find the ear opening, wings, and legs? During this time, the embryo continues to grow. The bones and beak begin to harden, and skin pores are visible. In this candling video, notice the area the chick takes up, the shape of the body, and size of the eye as it exercises in the egg. Can you see the legs kicking and the head region as it pushes off? During this time, the embryo continues to grow. The scales, claws, and feathers are completely developed. By the 15th day, the embryo starts to draw their small intestines into their body cavity. The embryo turns toward the blunt end of the egg to prepare to hatch. Due to the area the embryo takes up inside of the egg, it is more difficult to see as much detail. In this candling video of a 15-day embryo, notice the legs and feet kicking off and the area the chick takes up in the egg. By the 18th day, the embryo is fully developed and starts to prepare for hatching. The shell is basically full except for the air cell. On day 19, the embryo will start to draw what is left of the yolk sac into its body. This will help the embryo survive for a few days until it finds food and water. Again, due to the area the body takes up in the egg, it is more difficult to truly see the embryo. In this candling video of an 18-day embryo, notice the toes and feet kicking off and the area it takes up in the egg. During the 20th day of development, the embryo officially becomes a chick when it breaks into the air cell and takes its first breath. It is common to hear soft chirps through the shell at this point. These two clips show the chick's beak in the air cell and how they are starting to position to hatch. This video shows some of the hatching process. Be patient. It may take hours for the chick to hatch from the initial pip until they pop out of the shell. When they hatch, they are extremely tired and wet. Give them time to dry and rest before removing or handling the chicks. This video shows chicks at various stages of hatching, from pipped eggs to one popping from the egg. Make sure you show your students an important temporary tool the chick develops and uses during the hatching process. The egg tooth is only used to help the chick hatch. It usually dries and falls off within 48 hours of hatch. So, take time to show the students when you transfer the chicks from the incubator. They do not stay on the chick very long afterward. Isn't it amazing that all of this happens in 21 days from a fresh fertile egg to a chick? Enjoy sharing this miracle of nature with your students.
Okay, so that's just one example of the many videos that we do have, and you can imagine what some of the others are. At this time, before I go into the next slide, are there any questions about the 4-H embryology in a classroom program that anybody would like to ask?
You can go ahead and drop them in the Q&A. Oh, we do have one. What were the grades? What grades can participate?
It's meant for mainly second to sixth grade, nothing below second grade, because we don't feel like there's as much of an educational opportunity there as it would be for the second to sixth grade. And we have some high schools that do also participate in the program.
Great.
Okay, I don't see anything in Q&A, so.
Yeah, I don't see anything else coming through yet.
Then I'll just keep moving, and at that point, when we get at the end of the presentation, we can take questions as well. So the other thing they asked me to sort of teach a little bit, and I'm sorry, I didn't realize that was that way, but it is. I was going to talk a little bit about life cycles of different types of chickens, because there's a lot of misconceptions about the difference between egg-type chickens, meat-type chickens, and chickens you see somewhere like at a farm show, for instance, or a fair. So I was going to give you an idea of why poultry has become so different and developed genetically so different over time, and just give you an idea what the industry is really all about. So first of all, what really is starting this all was wild chickens. The Gallus or jungle fowl was basically, we have records that they were domesticated as early as 2000 BC. They graze and eat what they can find. That's why their crop is so useful to them. They can store feed that they do find in their crop region and then travel a good distance back to a roosting area that's safe and so forth. They tend to live more in jungle and brush areas. They don't like open prairie or open pasture area. They do like to be concealed from predation. They have very low body weights, but they're really good flyers. They're very much like a pheasant, much more like a pheasant than the domestic chicken we have today. The big difference between this and our commercial birds today, or even the birds that we've domesticated, is that most of these birds that were before they became domesticated, they're like a wild bird. They basically lay maybe one clutch of maybe 8 to 12 eggs a year, sit on them, hatch them, and raise up their young. Maybe a second time if they have a good season, it's a good mother. But typically, very few eggs are laid by these birds. They are good setters and mothers, however. They do very good job natural incubating. That is not something that our domestic birds do very well anymore because it's basically sort of been bred out of them, and I'll explain that in a little bit. And the other thing people need to understand, we hear so much about pasture poultry and birds running on pasture and so forth. There's two reasons they're not really good pasture poultry. One is they're jungle fowl. They're used to being in brushy, covered areas where they feel safe and so forth. And also our new birds, they are white, which makes them stand out even more, a lot of them. But the other thing is the grasses that are in most pastures where it's just green grasses, it basically serves as nothing more than some liquid and fiber. And it has a tendency to bind up the bird's gizzard, which is what grinds up their food, and isn't very good for the bird. So the alfalfa and greeny clovers are good for a chicken. You get omega-3s and vitamins from that. But grass really has no use to a bird. They don't utilize it. It's a stomach very much like a human. So if it's sort of like us living on iceberg lettuce for our whole life, that's what grass would be to a chicken. Chickens have changed dramatically though over the years. We've domesticated them. We've changed how we mate and incubate and multiply the birds. We've changed how they grow, how they eat, and how we manage them. So they all have very different life cycles. But there are some similarities between the wild type chickens and the domestic chickens we have today. First, basic physiological functions are the same. The egg forms the same, the digestive tract works somewhat the same. They're maybe a little more efficient and then in some ways for meat birds, but very little changes. Even when you look at the underlying genetics of chickens, even though they look so different, change so much, there's like close to 90% of the genes are identical. They're the same genes. Lighting is key to production, and that's the same with wild birds. They have to have a sustained light period in order to stay in production. So that's why in the spring of the year, when daylight is increasing, the wild birds are going to nest and having their nests. Domestic chickens need 14 to 16 hours of light a day to sustain egg production. So that's a lesson in itself. Most chickens are natural mating, just like the wild chickens. The egg develops the same in the reproductive tract. There's only one egg at the most you can have per day. And it usually takes between 23 and 32 hours a day, not a day, 23 to 32 hours from when the yolk is ovulated into reproductive tract until a whole egg is laid. So that's about a day's process. And if the next yolk is not ovulated within 20 minutes of the lay of that egg, you're going to have a day off. And a lot of that is also tied to the blood chemistry, which is a lesson in itself. I don't think I need to go into that in detail, but we have courses on hormones and production and so forth. And incubation is still the same. It's about 95 to 100 degrees Fahrenheit, and it takes 21 days to hatch a chicken egg. So all that's still very much the same of what we had before. However, things have changed. Once we domesticated chickens, we started taking and selecting for very specific things. First, we went with the purebred chickens. The purebred chickens basically were selected for some kind of appearance or trait that a human thought was pretty attractive or useful. And so some have a dual purpose setting where they were producing a little bit more eggs, but also had a little bit of meat on their carcass. Nothing like the meat birds today, though. And then we had people that developed miniature chickens and chickens that have all different kind of traits with frizzle feathers, different colors. the silky, which is still a feathered chicken. It's just that the barb and barbicil that holds the feather together and makes it look like a feather don't exist. So there's nothing to hook the parts of the feather together. So it looks like a poof. Most of these are from hobby flocks and small flock owners today. Very few, there's really is no commercial production of these. There are some mail order hatcheries that are sort of nondescript, almost like chicken mills in a way, but they don't really have purebred fowl or breed for purebred traits. They just sort of something that looks like whatever. These birds typically heritage breeds and these purebreds typically lay 30 to maybe 180 eggs a year. And there's very little fleshing on most carcasses. The Cornish is about the only one that's an exception. We'll talk about in a second. That had a mutation for double muscling that created a meaty carcass. And that still is a purebred bird as well as was used to start our industry. The American Poultry Association, which started in 1873, is the sort of the grandfather association that takes care of and sets the standard and everything for all the purebred chickens and turkeys, ducks, geese, things like that. So all these purebred fancy birds you see at shows or like a county fair or maybe farm show, they're the purebred heritage breeds. There's over 350 breeds and varieties of chickens that are recognized by the American Poultry Association. These were all developed all over the world. Most of it were moved around through merchant ships. A lot of it was credited to the fighting game industry at that time because for entertainment, when they went from port to port, they had their own fighting chickens on board, and that's how they entertained themselves at sea. And then they, bet things like that at ports and traded and did stuff that helped spread the genetics of poultry around the world. So the commercial strains are really a recent development, and I can't emphasize that enough. A number of breeds, though, did have significant commercial traits. The white leghorn, for example, up here that you see in the corner, those are the white egg layers that we use today commercially. It's the same breed. They're selected a little differently. They're not selected for the purebred traits, but for their production traits. They were the ones that started deliberately selecting for white plumage as well. Most of our wild type chickens and breed chickens are not white. White is also a relatively recent phenomena through mutation of breeding that just showed up white, not albino, just white plumage. And we started selecting for that because the plumage, when you're picking the bird and so forth, if you have pin feathers, that pin feather doesn't leave a dark liquid behind. It's a clear liquid, so it doesn't blemish the carcass. Cornish is the broad-breasted bird that had the double muscling gene. So it is a very meaty bird. What you see in that picture is all meat. You hold that bird, it's going to feel exactly like it looks. There's no loose feathers in that bird at all. So egg production, and what you need to understand as we move forward here is that egg production has a negative correlation with both broodiness and meatiness of a bird's body. So if we intensely select for egg production, we lose broodiness and we lose any kind of meatiness to the bird's body whatsoever. On the invert of that, if we select for meatiness, real meaty birds, we get very poor egg production. So the egg production goes down dramatically when you start selecting for meatiness. So that created a problem for the meat bird industry, which we'll talk about in a little more detail later and how we've gotten around that. Commercial emphasis started really in the first real record of any kind of utility classes. In other words, someone selecting for birds that were for meat and or egg production was at a show in 1913. Then in the 1930s, they started the Record of Performance Federation. It was a way of keeping track of how birds were growing and what kind of meatiness and egg production you were getting. Then the National Poultry Improvement Plan was put in place in 1935. And why that was so important is there were a number of different diseases. One was a salmonella-based disease called pleuron typhoid. It was a real problem in poultry because it got in the bird system and it spread between eggs in incubation. So even in a mother's nest, if she sat in a nest of eggs that had a kind of contaminated egg, it would contaminate other eggs. If the chicks even survived incubation, a lot of times they would die from starvation and dehydration and the disease itself at a very young age. But some always survived and were carriers. So our industry had an ingrained problem when we started artificially incubating. You didn't know which eggs were contaminated and so forth. So they started a program in which you could blood test adult birds for this problem. And what we did is eliminated any of those birds from being bred ever or being incubated. So it was part of the process of cleaning up the health of our national flocks to make them more able to survive. Let's just put it that way and do well. Oops, I'm forwarding again. Okay, so then in the 1940s, and again, when I say recent, you think about it, 1940s and 1950s, that's only about 70 plus years ago that commercial chicken production even started. So most of the modern breeding companies were started during that time. The Cornish Rock Cross became basically the breed or hybrid that we used to start off the commercial meat industry. So they took a barred Plymouth Rock, which you see here, which is a dual purpose bird, grew slow, didn't have a lot of meat, but had a big frame. And they crossed it with the Cornish up here, which is a real meaty double muscle bird. And they started mating there. And that's where the beginning of our ancestry to the meat industry today started, because they were more efficient, got bigger carcasses. Two contests and two experiment trials that we did is a chicken and tomato contest and the random sample testing that went on. Had a lot to play with getting producers and breeders around the country to enter records and compete actually for genetic selection and improving the egg production for some birds and the meat production for other birds early on in this industry. And then what we call vertical integration started in basically about 1950. Someone who owned a feed mill started a vertical integrated poultry company, and that's sort of the history that our company has followed ever since. That's why chicken is still, even in today's standard, much cheaper on a per pound basis and very similar to what it's been for 20, 30, 40 years compared to other meats. And chickens have evolved into three very different industries and types of birds. One is the purebred industry, which we talked about a little while ago, that still exists more as a hobby. The purebred egg industry, the commercial egg industry, and the commercial meat industry, all very different birds. So just to give you an idea, the modern poultry industry is it's vertically integrated and it's very international. The breeding companies are all international companies now. The equipment makers of both the processing machinery as well as the production machinery, feed ingredients, pharmaceuticals, everything in our industry is very large, very international, very integrated. And we have three major segments to our industry: the layer industry, which is our egg producing, our meat chickens, and our meat turkey. Those are very separate industries. And poultry production has become a science. And we'll talk about that as we go. So what we mean by vertical integration, if no one's been exposed to this before, this is what some people refer to as factory farming. But I need to have you understand what we mean by factory here and what is and isn't the factory part of this. So what basically vertical integration means is that a company like a Purdue, a Tyson's, a Bell & Evans, any of these poultry growers, okay, they basically have a processing plant. And then what they do is they typically have their own hatchery and they have their own feed mill. So the feed mill that provides the food to the birds, the hatchery which hatches chicks to make into the grow out birds, and the plant that processes all these birds, all is under the ownership of one company. They then do the further processing and sales. So basically they take care of all the processing, the sales, all that kind of stuff. Where the actual individual farmers enter in that own the land and the barns is for the breeder, the people that raise and are breeder producers that produce the fertile eggs that become the chicks that goes to grow out farms. And the breeders are different than the grow out farm birds. They're a whole different bird. And I'll explain to you why in a little bit. But these grow out farms, the farmer is paid, the chicks, the feed, everything supplied to the farmer, and they're paid on a efficiency and livability, all that stuff. So there's all kinds of parameters that they have to meet: livability of birds, efficiency, yield, all that stuff is entered into an equation. And if they're a really good producer, produce really good birds for the farmer or for the owner, which is like a Tyson's, they get a premium to their payment. Otherwise, they get paid so many cents a pound of meat produced based on that. And they're basically, they own the land, they own the poultry house that keeps them on the family farm because of the income they can make. They can make $26,000 to $36,000 per chicken house per year. And most farmers will have multiple chicken houses and then have other enterprises like crop farming or beef farming or dairy farming, things like that on the side in addition to that, because it doesn't take as much work to keep one person busy full time unless you have at least 3 or more houses. But anyways, that's what we mean by integrated model. So this is all controlled by one company though. And so they provide technical service, veterinary services to the growers, to the breeders. They provide that. A lot of our students that come out of Penn State end up being technicians that go to every one of these farms once a week. They go, if not more often, and make sure they're doing everything right and try to make their farmers more efficient, make their birds better, so that the farmer can do better, because then the service tech does better. So the whole idea is about efficiency and trying to make a better, healthier, safer bird is really what it comes down to when it comes to the whole process. So really, again, to emphasize this, the company owns the hatchery, the feed mill, the processing plant, and provides all birds and feed. The growers, on the other hand, or the farm owner, they still own their land, they own the barn, they provide labor, utilities, and the litter for the birds, and then they clean out the houses, and that litter is available to them to sell to other farmers to put down as fertilizer or to use on their own land. And the payment is based on a contract system that rewards efficiency, uniformity, and livability. And it's usually either on a cents per pound basis for meat, or if they're producing fertile eggs or eggs, they get paid so much per egg produced in addition to what they would get. So the layer industry, real quick, I'll show you 2 industries so we don't run out of time. They vary from 200 bird flocks to multi-million bird flocks. Just to give you an idea here, this lower picture here is in Iowa. One of our Penn State graduates, his senior year of college, helped plan this facility and build it. It's a 4.2 million bird inline egg breaking pasteurized egg liquid egg plant. All they do there is produce liquid egg and put out 5 tractor trailerfuls a day for consumption. That's what they do. And so you can see they have composting barns that compost litter. They're really all out there. They do a really good job. What you see here is a pasture or a free range organic type of operation where they have to have outdoor access. You can see how few birds are outside. That's normal. They don't like to be outside that much, especially if they don't have a lot of cover. But you'll see what the inside house looks like in another picture in a second. Just to give you an idea of the size of this industry, typically there's around 320 million laying hens commercially on the ground at any given time in this country to keep our market going. So how it works is the primary breeders and multiplier flocks are owned by international breeding companies. They're owned by companies that do nothing more than develop the genetics for the next generation. The females don't have setting instincts at all anymore. These birds have been selected so intently for egg production that they don't even have the instinct to set anymore. So typically all these eggs are artificially incubated. It also increases the egg production of these birds to make it more efficient to get offspring. Still takes 21 days to hatch, like I said. These birds are then raised in environmentally controlled buildings that are either cage or floor reared, depending on their next step in life. If they're comfort cages or if they're in a totally floor setting, they're reared in a setting that makes them prepared well for the next part of their life. And they're raised that way for 16 to 18 weeks. Then they're transferred to laying facilities. And so there's 2 laying facilities in this picture here. This is the other side of that outdoor run. This is a cage-free chicken house. You can see the chickens are free to go anywhere they want in there. They got roofs all over. They have nesting areas that they go into. The eggs roll away from them and they get collected on a belt automatically, just like these in the comfort cage environments. All their feed runs in front of the cage. The eggs roll out and they go out. They get collected on a belt. They have nipple watering systems inside. They have secured areas where they can hide if they want to lay. They have places to scratch. They have places to perch, but they're in more of a controlled setting. We found through years of research that these eggs are much cleaner. There's not food safety issues. We don't have cannibalism and picking problems that we have within a mean, very pecking order related chicken flock. We have a lot less contamination of eggs, have a lot lower mortality. Our mortality in the cage houses is about 3% for the life of the birds, where it's almost 14% in the life of a cage-free flock because of all the issues we run into with getting into gut diseases that we don't have in cages because they're not in contact with manure. We don't have pecking problems, a lot of things that go along with that. So real quickly, only females are raised in commercial chicken houses. Males have absolutely no use. Other than eating feed, making some noise and creating problems, they really don't. So it's just females in these houses. So these eggs are not fertile. The feeds they're fed a very specific high calcium diet that just meets their dietary requirements for the age the bird is. They actually tweak the diet to keep their body and their bone calcium levels and so forth just so. They're given 14 to 16 hours of light a day. They start laying around 20 weeks of age, and they will lay efficiently for 70 to 80 weeks after that before they start losing their efficiency and get less than 55% production within a flock. At that time, the birds can be molted or processed, and we'll talk about that in a little bit. White egg layers today, we get easily, the national average is getting real close to 280 eggs a day per bird. Not per day, I'm sorry, 280 eggs per year per bird is sort of a national average range right now for white egg layers. It takes about 3 pounds of feed to produce 1 dozen of eggs. And the brown egg layers are a little bit less efficient, but they're getting very close. Their averages now are in the upper 160s, but they have that range right there. So what happens once they roll away from the nesting area on those belts I showed you? They basically get on a conveyor belt and come right down to a washing machine. The eggs automatically washed. They're automatically packaged and put into cartons. And then the people basically put the cartons in the boxes. Any more robotics are even doing that. The ones that are in line, they wash and grade the eggs. They sort them by size. And they actually can break liquid breaking plants. Humans never touch any of this. The machine, after they're washed and everything, they automatically break the eggs, separate the yolk, separate the white, and then reconstitute it as necessary. All eggs are basically packaged and shipped and in the grocery store within 4 days. So, when we talk about supply side issues and so forth there, part of our problem back in the days of supply side was all these liquid egg plants, because the USDA standards weren't able to set up and package those eggs. We lost the restaurant trade, lost the school trade, and there was nowhere to sell liquid egg anymore. But they had no way, because of USDA standards. It took them a while to get that approved by USDA and get all fixed. But all those eggs are being disposed of. Literally millions of eggs are being disposed of because we had no way of putting them into the consumer marketplace because of USDA standards and regulations and everything. Once that opened up, they start to be able to send some of those as cartoned eggs into the industry, but it took months for them to get beyond that. So what happened, everybody went home, started eating eggs at home, not at schools and restaurants and on the way to work at fast food places. So that the egg demand for carton eggs went through the roof, but we couldn't give away a liquid egg. So that's why we got into supply side issues. So now when you look at the broiler industry real quick, just to show you the difference, because I know we're going to run out of time if I don't, is there's about 9 billion birds that are raised for meat in this country every year. So if you look at what we've done there, all these things have had a huge impact on the overall ability for us to raise chickens very efficiently and very humanely. Two of the biggest things, other than genetics had a huge part of this, and some disease controls and other things. But nipple waters, it sounds crazy, but you can't really see too well in these pictures. I tried to show it here. These little white caps on there, and these little things you see hanging down here, they're not real good. Should have got a better picture. They're little plastic mechanisms that have a little metal trigger in it that keeps a droplet of water on it. And the birds reach up at that droplet, it runs right down their throat because they swallow through gravity. It's very efficient, keeps the houses very dry. It's been one of the best things we've come up with for raising commercial chickens in mass like this. Tunnel ventilation is the other thing that's good. They have this house sealed on the sides, have a huge bank of fans on one end and an open end at the other end, and they can move air so well across this house and use misters. If we have a 90-degree day with high humidity, we can actually have a house that's 20 degrees cooler for the birds than the outside temperature. And the birds are like happy as can be in there and not worry about pneumonia and other problems. So all these automatic feed systems, watering systems, here's a flock that's getting ready to go to market. Here's a chick, that's what the flock looks like when you place them. And that's what they look like when they're about ready to go to market. So they're thick, but they have a lot more movement than people realize. And they don't move much. These meat birds eat and grow, and that's what they do for a living. And how we've gotten here, so you understand, is remember I said that negative correlation was there between meat and eggs? Well, what we've done, and we've produced hybrid strains of birds. So we've developed male lines that bring in the efficient meat production, and we developed female lines that are more relatively good producing birds that bring the production traits over. And so we make these male lines until we have an AB, two male lines that are crossed. The male of that line is then crossed with the two female lines that come together with the production traits, so that the company gets these birds, like the Tysons, the Bell Nevins, the Purdue's, those companies get these birds from an international breeding company and cross them on their premise. And then the four-way cross, we have all four influences in the offspring. That's the bird that is consumed and raised for production. They're very, very efficient, very, very fast growing, but they're not meant to be kept as breeders or lay eggs. They're meant to be to market within 5 to 10 weeks. So we used to select in the 60s for weight gain. Today, we select for all these things. When you go to national, international breeding companies and stuff, they have almost like a medical hospital right there with their birds. They test and they do ultrasounds. They do cardiac tests. They scan the entire bird structure for perfect bone strength and perfect bone angles and so forth before they even breed them. So now we've gone so far away from just growing a big bird to growing a big bird that has a structure that can handle it as well, which is good, because when we first started back in I was late 70s in college, we had problems with lameness and some other issues that were based because we're growing the birds too quick for their structure. We've caught up with that now, and the structure now can handle a lot of that growth. Just to give you a quick idea where we've come, in 1923, our birds went to market in 16 weeks at a live weight of 2.2 pounds. Now, I got to realize the yield on that is about 70% meat at the most. And it took 4.7 pounds of food per pound of meat, with mortality running in 18% range. In 2010, we had 5.5 pound live weight birds, again, 70% yield, on 1.8 pounds of feed per pound of meat produced. Today, we're closer to 6 pounds and 1.6 pounds of meat 1.6 pounds of grain or food for every 1 pound of meat produced. And our mortality is at around 3% on a national average. And these birds reach that weight by 5 weeks of age. Just to show you, North Carolina State kept some old Arbor Acre birds that were the 1957 Arbor Acre birds. And what they did is they kept that line intact. They didn't allow it to improve. They kept it right where it was forever. And they take the Ross birds in 2001, and they used a commercial diet where we've learned a lot about mixing diets, so forth, for best optimal growth and so forth. They fed the old 1957 Ross birds, and Arbor-Acre birds, the 1957 Arbor-Acre birds. They fed the 2001 Ross males on the standard feeding. And at 43 days of age, 57, 71, and 85, these are all exactly the same age, above and below each other. And that's the meat conformation because of genetic selection, of selecting the top 10% of your meat producers every year to get to that point. So we've been able to make amazing strides to get good quality meat out. Basically, like I said, they get them from the process, they get them from the primary breeders. Their breeder grow-out farms at these farms, grow them to 20 weeks. They put them in a breeder farms. The males and females actually have separate feeders, and so that the males can only reach to feed for them. Females can only get their head into feeders for them. So they're fed separately for optimal production. Females start laying 24 weeks, and they lay for 40 to 50 weeks, and you still only get 150 to 180 eggs out of a broiler female. They're not nearly as efficient as a leghorn, but a whole lot more efficient than 30 to 100 eggs maximum. Again, 21-day incubation period in large incubators. They're raised on the floor only. We only raise meat chickens on the floor, period, in very environmentally controlled conditions. They're raised from 5 to 8 weeks of age, and they have a 4 to 8 pound bird in that time. And the birds are raised for very specific purpose. So if you're doing a fried chicken that you buy at a grocery store or at a restaurant, typically that's what we call a 3-9 bird. That's a bird that's around the 4 pound weight at 5 weeks. And that's for that. When we do cut up meat, big breast fillets, so forth, those birds are raised to 8 weeks, a whole different breed or selection of birds, and they go to much larger size. Turkey industry, real quick in a nutshell, basically the same as the meat industry for chickens. Two big differences is turkeys are all 100% artificially inseminated. And the big reason for that is these stud toms that we raise for the semen run about 90 pounds. And they just do too much harm to the females. And they are so expensive to raise, maintenance and so forth in the first place. It's cheaper to raise them in small groups and milk the male and extend the semen and artificially inseminate the females than it is to try doing natural mating. It's just more safe for the birds and the humans, everybody else. Real quick, I just want, for those of you that have higher grades, I just want one slide put in here, is there are a ton of opportunities for college graduates in poultry. It is a science. It's amazing the science that's involved. And I cannot get enough students. I place every student you give me. Every job, almost every student anymore, if they want to get it, has multiple job offers. Average starting salary this year is about $55,000. This is last year's range. This year it's going to be a little bit higher. The lowest one I know right now is at $48,000. So this is starting salary. Typically get a pickup truck, a computer, a cell phone so that you can drive around to these different places and so forth. That's provided by the company, and some really good benefits. So if you've got anybody interested in animals, in science, there's a lot of opportunities out there for students in the grow out, the processing, the food safety, the auditing, you name it. It's a huge industry. Last thing, biosecurity. Some of you may have remembered this back in the day, but a high-path avian influenza is out there again. We've had multiple cases in the Atlantic and Mississippi flyway. That's the blue lines here. Green lines is Mississippi flyway. Starting in January, we've had numerous, I mean, we're talking dozens of cases of wild waterfowl that have been tested positive for avian influenza high path in all these areas. Carolinas, Virginia, Maryland, Canada. The 7th 12,000 bird turkey flock in Nova Scotia had to be destroyed because of being exposed to high path avian influenza and becoming sick. This week, we had a flock of 29,000 birds, 3 houses in Indiana that also came down with high path avian influenza. So it's in our flyways again. So the industry's got to take a lot of precautions. This is something we learned about during COVID. How do you keep things from getting sick? Well, a big thing in our poultry industry, we don't want disease getting in our premise, and we don't want, if we have it, get out. So we do an all in, all out in our commercial industry. In other words, we never bring any kind of birds into a flock once it's established. They all go to market at the same time. They all start as chicks at the same time. We keep our birds confined and not out running for reason. Matter of fact, all the organic and pastured poultry operations on the East Coast right now have been granted permission to keep their birds indoors so they don't get exposed to wild waterfalls, so they don't have to dispose of them and get sick. So they actually close the outdoor doors on organic and pastured poultry right now. By law, they have to do this is protect the birds. We never bring in chicks. We control traffic. They do not let just Joe Public come into premises very often at all. That's why it's hard to get tours of these operations. And it's not because they're trying to hide anything. It's because they're trying to keep any opportunity for any disease, foodborne disease, illness, anything from getting into these birds and flocks. They are very protected. We never have mixed age birds on premises, and we keep our environments very clean for a reason. We have to. So there's a site, healthybirds, aphis.usda.gov, that talks about this if you've got birds yourself or if you've got kids that are interested in this. Poultry industry, when it came to COVID, I had no trouble adjusting to everything because I knew exactly what we do in our industry, have been for years, and I knew what I needed to do to protect myself. The only thing we added to humans is we don't put masks on chickens. So as far as hand sanitizing and not being exposed, we knew what that was all about. The biggest thing for poultry we find is that dirty shoes and hands are our biggest risk. So most premises never let anybody on premise. Even if I go visit a farm, I have to boot up, suit up, and make sure that I have nothing on my clothing that can be exposed to the birds. And that even in our poultry center here at Penn State, we do not allow visitors at all, normally for 24 hours after you've been near poultry. But now we're extending it because of avian influenza to 3 days. If you've been around poultry for 3 days, you can't even tour our facilities right now. That's just to protect ourselves and the birds. So that's a lot in a nutshell. That's a lot of information. So let's see what we have for questions, and don't be afraid to put questions in there. I'm going to stop sharing so I can see things here and do Q&A. Thanks for bearing with me. We got a little long, but we started a little late. What typically happens to the chicks after they're hatched? Do students' families adopt them? Yes, they do, but there's a special protocol that they have to take. It's the responsibility of the program to find homes for that county's chicks. So the county extension educator is responsible for making sure all the schools have that lined up prior to doing the incubation project. A number of the counties have farmers or others that are looking to take these chicks. They actually have some agreements with like, I shouldn't be using names, but Tractor Supply or farm supply stores that have chick days. They actually take all the chicks and then sell them to, or give them to people that want to raise chickens and sell them some feed along with that type of thing. One thing we do though, is there are some zoos and reptile centers, things like this, that typically have to buy chicks from hatcheries to provide nutrition for their animals. And there are some that actually do take chicks and so forth to some of these centers as food, because it's unfortunately a part of the cycle of life, but it's something that they would have to pay for otherwise. So it's actually helping them as well. So that's where some of them do go, to be honest with you, but most of them go to homes. We just do not allow teachers to just give a kid 3 chicks to throw in a box, take home on the bus to their apartment. That does not happen. They have to prove that they have facilities to raise the birds. The parents have to come to school, pick up the chicks to take them home, and they have to have facilities. So what % of commercial eggs produced for consumption are fertile? 0. Unless you buy specialty eggs that are produced by a very small producer, these typically aren't considered commercial producers. They're less than 15,000 birds. Anything 15,000 birds or more is considered commercial. Anything less than that is really a small flock. There are some people that will sell backyard eggs or special groups to fertile eggs, but no commercial chicken eggs will be fertile by nature. They don't have any males present. I teach high school biology and would like to encourage my students for a career in this industry. What would you recommend that they major in at college? Well, I would recommend, my first recommendation is that they attend a land-grant university where they have a college of agriculture, because that is science. So in Pennsylvania, we've got Penn State University. There are some courses in agriculture at Del Val in Pennsylvania. I'm not advertising for them by any means because they don't have majors specific to it, but they do have agriculture and they do place people in our industry. There are other ones, surrounding us, the Virginia Techs, the Cornells, the Michigan States, the Purdue's, you keep going. Anything that's a land-grant institution has an agricultural college, will have agricultural business, agricultural engineering, food science, animal science, poultry science. We have a poultry science minor here that is very successful, like I said, and we're so our students are real highly sought after. So any major that gives them a good exposure to working with people, and realize, I guess what the thing for the students realize is that the industry really is all about producing protein in a safe and efficient manner. So anything that helps them understand chemistry, biology, business skills, people skills, microbiology because of food safety issues, those type of things, and good communication skills, anything like that. If they're interested in this industry, they need to learn some science. It's real important that they get some chemistry, some biology, because everything we do in our industry is science. I don't care if it's at the processing level and food safety to feeding the birds to, safety and everything else. So there's a lot of things. If you're interested, you've got students interested, contact me. My email address was in the chat. We even do college visits for students that might be interested in this type of a field on a regular basis. We do visits for families and get them into PERC, things like that, and show them close and personal what we do here. Just we need to coordinate it in a way that they're not around birds for 24 hours or whatever and that type of thing. But be more than glad to work with you. If you got any other more specific questions, either contact me or put them in the chat. I always thought all eggs were fertile, but no commercial eggs were fertilized. Nope, no egg is fertile. When you looked at, remember that germinal disc in that video I was showing? Every chicken egg has a germinal, blastoderm. That's what we typically call it. Or disc. I'm showing a disc is non-fertile. A derm is when it's fertilized. I'm just doing two things at once here. I got to stay on my train of thought. So basically, every egg has the female's DNA. That is fused to the yolk. It's part of the yolk structure as that yolk develops in the female's ovaries. Once that yolk releases from those ovaries, it drops into the reproductive tract. It's two separate organs. They're not even connected. There's like a pouch that catches the yolk, okay? Once it enters that, if the female is mated with a male, there are what they call sperm nests in the uterus. So a female can stay fertile for up to 4 weeks after she's been mated with once, typically. But typically they mate them more to give a really big surge of sperm in the uterus so that it holds fertility well for a long period of time. And then they're artificially inseminated, or they're allowed to mate within 7 to 10 days. They usually mate, or more often. But if the sperm is present in the reproductive tract, then that travels up the length of the reproductive tract and in the infundibular, which is the first part of, I should have played that video for you guys today. The first part of the reproductive tract, that's where the sperm will fuse with that blastodisc on the yolk surface. And once the sperm penetrates that and basically fuses with the female cell, then it becomes the blastoderm or germinal spot, and it grows actually while it's in the female's reproductive tract for that 23 to 32 hours because it's at body temperature, so the cell division can continue. And so when actually a fertile egg is laid, that germinal spot looks totally different. It's about 7,000 cells, nothing to differentiate into a bird or anything yet, but the cells are there to set themselves up to move on to the next layer of development once it's incubated. And the egg can go dormant after it's laid until it is incubated. So no, nothing is fertilized unless they're with a male. And we don't raise males with the commercial chickens. It's just a waste of feed, and they create a lot more problems than help. So no, all commercialized eggs are not fertilized. So don't try to incubate eggs from a commercial grocery store. Make sure you go to a small producer, or maybe you can find some places that sell fertilized eggs, but typically if they're sold in the store, they're stored at too cold of temperatures for the germinal spot to stay viable. And so they won't hatch very well unless you get them from somebody that are producing fertile eggs specifically for incubation. Confusion on question 2 on pretest. Answer: none was marked incorrectly. What is the correct answer? I don't see that in front of me. So which question is it?
That was the question. I just pulled it up, and that may have been my fault. What percent of commercial eggs produced for consumption are fertile? So that may have been my fault for
It should have been none.
Tagging the wrong answer. Yeah.
Unless I did it wrong, but it should be 0. There's no eggs that are fertile.
Yeah, I think that was my fault. Sorry,
okay.
Everyone.
Okay. And then what happened? That happened for me as well. I chose none. Okay, you're good. So you'll get credit for that being correct. They'll fix it, I'm sure, or can fix that, or whatever it needs to be done. So are there any other questions out here that I'm missing, or that we need to address? Okay, that's where you're confused. Okay. Fertile is an egg that is able to be incubated into a chick. Okay. Non-fertile eggs are what typically you have. A chicken lays an egg unless it's mated. The egg that is laid is considered not fertile or non-fertile. It can never develop into a chick. An egg that is laid by or being developed by a female, if it is mated, sperm can fuse with the yolk, the germinal spot on the yolk, before the rest of the egg is put down and the shell is formed. So if that egg is fertilized, then it is fertile. If it is fertile, it can develop into a chick. But every egg that is laid otherwise, unless mated with something, is a non-fertile egg. It is not fertile until the chicken's mated and sperm actually fuses to the germinal spot on the yolk. So there actually can be, even in a breeding farm, we have a certain percent of eggs that still show up not fertile because spermatozoa was not allowed to travel properly or fuse to the germinal spot before the rest of the egg was formed around that egg. So that, hopefully that helps. Okay, you asked about size, how eggs are sized. They're done by weight. And it's real simple to know weight. If you want to know if you're getting a good deal on eggs or not, just learn that there's a 3-ounce difference between every egg weight. A large dozen of eggs weighs 24 ounces. And if you go down or up 3 ounces, you go to the next size. So 27 ounces is extra large, 30 ounces is jumbo, 21 ounces is medium, and then 18 ounces is small. So if you're buying eggs, they're always sized or weighed on ounces per dozen. 24 ounces is for large per dozen, 24 ounces per dozen. But yes, that's how we sort eggs and sell them by size. We also, grading is not a nutritional factor. It's just a convenience for consumers to know that the functional properties of the egg will be good, so that when you make a fluffy angel food cake, it's going to turn out right and not flat. If you've got old eggs, they'll turn out flat. That's why you want grade A or better, preferably AA fancy if you want a really good one. Yes, very different from a human reproductive system. But think about the birds in wild. Even pheasants to this day, and a lot of wild jungle fowl, they don't stay together as a flock. The male normally stays separate of the females. And so they only mate when they get in contact with each other or they need to mate. Otherwise, they're not mating. So they may be together with that male for a short time, and then they need to lay 1 egg per day to get a clutch. So they're not together much more than maybe a little short time. So they actually can store sperm in their reproductive tract for 10 to 14 days is optimal. After that, you start seeing a drop in the curve of fertility. But we've got records of birds being fertile for up to 4 weeks. But yes, it's very different. There was some research, red contacts. Is it true that red contact lenses were used in the poultry industry in the past? There was actually some research done, and they were used some for a while in the industry. And the reason they were using those is because of the cannibalism. The chickens are not a nice critter by nature. I mean, those who have chickens, don't shoot me. I've had them for years too. But they can be very aggressive and very nasty to each other if they choose to be. And when you start putting birds in confinement in larger numbers, that sort of magnifies and multiplies issues with that. So what they try doing is they know that red lights, for instance, certain light spectrums makes birds more docile and makes it less, gives them less ability to see red if there's blood. If one gets picked and blood forms because a feather gets pulled out that's still got a bloody tip on it and a little blood's there, if they start picking at the blood, then they start picking and hurting the flesh and making more blood. So what they used to use is red lights to keep them from being able to identify blood and so forth. One of the things that they tried for a while was red contact lenses in birds that they had problem with cannibalism. They put these little red lenses in, so everything they saw was red, so they couldn't pick. It wasn't economical. It wasn't something that is even worth doing. One thing to go off of that real quick to give you an idea of how much we've improved that. First of all, we bred a little bit of that aggressiveness out of the birds through selection over the years. And then the other thing is we now know that birds see at a totally different light spectrum than you and I. So that's why those have been around birds in the past or get up earlier in the morning, hear the wild birds making all kinds of ruckus in the morning, it's still dark out. They see at a different light spectrum than we do. So for them, it's daylight already or dawn. For us, it's still pitch black outside. So we now have totally different lighting for chicken houses than we use for humans. We don't use incandescent bulbs anymore with that yellow spectrum. We use more blue-green spectrums because the birds stay much more docile. They are much more efficient and feel much more relaxed and less stressed. So we're really come a long way with the new LED lights and the lighting systems we have today. It is really, that's been another great innovation for our industry that's really helped in the health and the whole humane aspect with the birds. It's helped us a lot. Okay, next, are a hen's yolks predetermined? Hey, that's really getting into some good questions here. We actually have 2 professors in the department that do nothing more than study the hierarchy of yolks in the birds. There is a hierarchy in yolks, and I wish I had a picture I could just pull up really real quick, but the hierarchy yolks is if you ever post a chicken that's in egg production, the reproductive tract, there's literally, in the ovaries, there's literally thousands of ovum, okay? And some are very small. I mean, they're almost like the tip of a pen. They're so tiny, or tip of a pencil. But there's a clump of them that's about the size of a pea. There's a bunch of them. I mean, there's probably, hundreds that are about the size of a pea. And then once the hierarchy kicks in and they get pulled into the hierarchy, there's 14 yolks in progression that you can see that are different sizes. So, matter of fact, no, I don't. I thought I had a poster I could pull up real quick. I don't. But the hierarchy there, you can actually take the yolks and you can separate them by size in just the visible size of these yolks. You can take them and remove them from the ovary and lay out the next 14 sizes and know which are going to be the next 14 yolks to be laid. You can do that, but we do not know, and that's where the research is. We're working at the cell level now trying to figure this out. We cannot yet to this day figure out why a given yolk is determined to be the next one in the hierarchy. We don't know what gets them from that one point, that medium point, to next in the hierarchy, so that 14 days from now, they'll be the next yolk coming off. That we don't know. But yes, the hens' yolks are predetermined somehow. And we know once we get to that, once they get into the hierarchy, we can tell you which 14 are going to be next. But until they get to that hierarchy, we have no way of determining which one is selected, if it's random, or if there's a very specific reason why one is selected. That's a very good question. You got kids that are interested in research. We've got reproductive physiologists working on that all the time. Is the hybrid breeding considered GMO? No, it's not. We're not modifying any of the genes in these birds. If poultry just took and basically cloned our chickens of the 1950s, you saw what they'd look like today. There'd still be skin and bones and a little bit of meat. All of our selection has been from intensive selection processes. Think for 1 second. In 20 weeks, 21 days to hatch an egg, in 20 weeks, 24 weeks really for meat birds, so let's give it 24 weeks. So that's in 27 weeks, we have a female that can start mating with a male. They can lay average 160 eggs a year. So in 1 year, we can get 160 matings off of that one pair. If we take the top 10% of the efficiency, meat growth, and so forth off of that one bird, that's just take 1.6 birds, so say that's fraction, but say 1 or 2 birds, the 1 or 2 best birds from that standpoint. Now you look at literally thousands of matings that we can do, 160 eggs per bird, and we can take the 10% best growth from meat standpoint and efficiency, all these different parameters we look at. We've been able to make tremendous progress in just selection. It's all totally done by selection. And it's amazing what we've been able to do. When I was in college in the 70s and 80s, the professors back then thought we were at the end of our rope. We had birds going to market at 10 weeks at 4 pounds and 2.6 pounds of feed per pound of flesh. And here we are today going to market at 5 weeks with 1.6 pounds and over 4 pounds. You just can't hatch a 4-pound chicken. It doesn't work that way. But the metabolism of these birds has changed dramatically. So we light the birds differently. And as long as we keep the bird full and the gut is able to absorb nutrients, it's growing. The bird's growing meat. It used to be, we used to feed the bird, just splash them a little bit of food, and it's cracked corn with a little bit of energy, not much protein, vitamins, and minerals. We learned a whole lot about how to feed these birds to optimize their efficiency and make them grow in a way that we're not making as big of a dent in our environment. I don't know if anybody saw an announcement this week. Tyson's put something out about how much feed they use a year just for their company. They buy and work through enough grain to basically plant 2 areas the size of New Jersey. Just Tyson's alone, 2 fields the size of New Jersey worth of grain to feed all the chickens they feed the world. Okay, think about that for 1 second. That's a lot of grain, but that feeds a lot of people. So we look at a lot of different things like the cage system in pasture. If we put every chicken that lives in Lancaster County on the pasture setting that some people were trying to push out at one point, there's not enough land in Lancaster County for the chickens alone. Okay. Cal-Maine, the largest egg producing company in the United States. If they had to go to totally cage free, their footprint for barns and for grain, because of the inefficiencies of the birds that are in that environment, would add another 750,000 acres of land would have to be used for barns and grain in order to raise the same birds they raise today. So we need to think about some of the things that we do and how it's complex and how everything's intermingled through the things that we do as a society, as far as efficiently producing food for the people. What's the best way? So that's an interesting way to look at it. But a lot of people don't realize the consequences of some of the things that some people feel we need to do. think I saw something in chat. I can pull my chat up too. Yeah, you're right. I mean, it takes the smaller animal takes a lot less space. They grow a lot quicker. The only thing that we can grow protein better and quicker than poultry is fish. Actually, there's some fish that actually are more efficient than poultry about converting to protein. But yes, you're right. It takes the footprint isn't there as great either. Any other? The only disadvantage of chickens is they compete with us for grain because they have their digestive system is so much like ours. They need grain to produce protein, and that competes with the humans some. Whereas large animals like cattle, for instance, they can utilize things like hay and fibers that a lot of us can't utilize to use their ruminant stomach to create protein that you and I can't. But along with that, then you have emissions and more water, a few other things too. So I understand where you're coming from. Oh, one big tangled, it's amazing. Is there any other questions? We've been on a little bit longer than they said, but I'm willing to answer them. What I'm here for.
I don't see any others coming through.
They probably want to go home. It's a Friday afternoon.
Was
If
a
they're
lot
not
of
home
good.
already.
Yeah, that's true. That was a lot of good information. That was very interesting. And thank you for staying and answering all these questions.
Did I cover what
Awesome.
you were looking for?
Yeah, definitely.
Okay, so I tried making, because it was kind of, you sort of gave me an idea what to cover, but you really didn't, you let it pretty wide open. So I was just trying to figure out what would be the best thing to engage them. So hopefully that's helpful.
I think it was very helpful. I think
Okay.
you did an awesome job. Thank you.
Okay.